Before starting our presentation, I'm going to introduce my group member. First is Siti Munira binti Zainuddin, Edeni Anak Mas, Nur Nafika binti Azan, and I myself is Muhammad Afif bin Abdullah.
Hi and Assalamualaikum. Okay, so the name of the software is Mobile Discovery Net MODISNet. This application system is used to monitor the pollutants and analyze their effects to the environment by collecting real-time pollution data on key aspects of traffic, conditions, emissions, ambient pollutant concentration, and human exposure. The purpose is to develop the capability to measure, model and predict a wide range of environmental pollutant and hazard using a grid of pervasive roadside and vehicle person mounted sensors. MODISNet system will construct a grid environment which fully integrate existing static sensor system and complementary data source with the mobile environmental sensor system and complementary data source with the mobile environmental sensor system, which will provide radically improved capability for the detection and monitoring of environmental pollutants and hazardous materials. The key feature of the MODISNet system is to use a variety of vehicle fleets, including buses, service vehicles, taxis and commercial vehicle, a platform for environmental sensor. With the collaboration of the static sensor fixed on roadside, the whole system can detect the real-time air pollution distribution in selected places.
First problem statement is road traffic make a significant contribution to emission of pollutants. The example of pollutant is such as benzene, carbon monoxide, lead, nitrogen dioxide, ozone, particulate matter, PM10 and PM2.5 and sulfur dioxide. The second problem statement is increase of car ownership and use in urban area. Road traffic generate chemical emission to the air to form air pollution. In various weather conditions affected by temperature, wind, humidity, pressure, etc., these pollutants cause different air qualities. Air pollution can contribute to the risk of heart attacks among people with heart disease. When women being exposed to the polluted air, especially in urban area, driving in heavy traffic near the highway or at the downwind location, with the doors response, people may suffer breathing problems and asthma attack, which will contribute to risk of heart attack among people with heart disease.
Objective of our project is to develop the low-cost mobile environmental sensor system. Second, to provide radically improved capability for the detection and monitoring of environmental pollution and hazardous material. Third, to propose a highly effective air pollution monitoring system. And lastly, to provide a solution of executing the real-time distributed data mining in sensor grid.
The location for this research is a typical urban area around the Tower Hamlets and Bromley areas in East London. There are some of the typical landmarks, such as the main road extending from A6 to L10, the hospitals around C5 and K4, the schools at B7, C8, D6, F10, G2, H8, K8 and L3, the train stations at D7 and L5, and gasworks between D2 and E1.
For the next one is research methodology. The first one is MODISNet network architecture. The mobile network formed by the mobile sensor node MSN and the static sensor node SSN. MSN are installed in the vehicles. The pollution data will sample and the AD will execute conversion to get digital signal. SSN take in charge of the data receiving, data storage and action works. The second one is GUSTO sensor unit. GUSTO is designed to quantify the relative concentration of a set of urban air pollution in real time. When a vehicle passes within the vicinity of the sensor, key pollutant SO2, NO2, O3, etc. emitted by such vehicle as UV light characteristic frequencies and then detected by the GUSTO sensor. The third one is eSigns and Grid. eSign is associated with computer network architecture that enable the global collaboration. A sensor grid over a typical urban area around the Tower Hamlets and Bromley areas in East London. There are 140 sensors are distributed in this area and collected data at 8 am to 6 pm at 1 minute intervals to monitor the pollutants of NO2, NO, SO2, and O3. A mobile sensor data grid was developed for processing, integrating, and analyzing heterogeneous sensor data. The fourth one is peer-to-peer, P2P based distributed data mining. P2P in network data mining is based on data collected and stored by each sensor in real time. The air pollution analysis uses the air pollution data to give an overall understanding of the air pollution characterization within this area by running the data mining algorithm. In this data analysis scenario, the distributed clustering algorithm will use to cluster the pollutants into pollution clouds, which can recognize different pollution patterns. From the experimental result, will pick up all the high pollution level locations at 9 am, 3:30 pm, and 5 pm respectively to check the contribution of different pollution to the pollution level.
Next, I'm going to explain the result part. So from the figures, we can see that in the morning at 9, the high pollution locations are distributed around the main roads and the schools, which is highlighted by the circles. At 3:30 in the evening, the high pollution locations are around the schools and the factory, which is a gas work and highlighted by the square. At 5 in the evening, more pollution focuses on the main roads, the hospitals highlighted by the ellipses, and the factory made the contribution as well. From the table shows, in each time snap there are 3 different pollution clouds, which are red, blue, and yellow. Each cloud represents a kind of combination of the 4 pollutants. For example, in the morning at 9 am, the red cloud that covers the main roads and the area around the main roads is characterized by high volumes of nitric oxide and sulfur dioxide. Most of these pollutants are emitted by the vehicles running in the morning rush hours. According to the environmental reports in UK, the road transport sector is the major source of nitrogen oxide emissions, especially in urban areas, contributing more than 50% to the total emission. Besides, the solid fuel and petroleum products are 2 main contributors of sulfur dioxide. At 3:30 in the afternoon, the blue clouds cover the school areas, which are in high volumes of nitrogen dioxide and ozone, with low volumes of nitric oxide, while yellow cloud featured by high volume of sulfur dioxide covers the factory area. As nitrogen dioxide and ozone are all formed through a series of the photochemical reaction featuring nitric oxide, carbon monoxide, hydrocarbons, and particulate matter, generating nitrogen dioxide and ozone needs to take a period of time. That is the reason that the density of nitrogen dioxide and ozone in the afternoon is higher than that in the morning traffic peak time. At 5 in the afternoon, it seems to be the worst pollution distribution time within a day. Besides the transport emission around the roads and the factory emission, some other locations such as the hospitals contribute some kind of pollutants, including the sulfide and nitrite. On the rightmost of figure at 5 in the afternoon, a yellow cloud covering a main road from M1 to L10 contains high density of sulfur dioxide, nitrogen dioxide, and ozone. The pollution pattern is very similar to the pattern at the factory and hospital areas, but not similar to the pattern on the other main road from A6 to K10. The researcher investigated this area and found that a brook flows along this area in the near east, and a factory area locates on the opposite side of the brook, which is beyond the scope of this map. This can explain why the pollution patterns are different on these 2 main roads.
So for the conclusion, this journal it has provided an overview of the urban air pollution analysis within MODISNET project, describing the network framework, the GASTO sensor technology, the mobile sensor grid, architect, and the distributed data mining algorithm. For your information, the system can achieve a high performance based on the high quality mobile sensing capability of GASTO sensor unit, which can measure pollutants at very short intervals. There is another way of design the Fuchs and aggregation algorithm with the integration of novel routing protocol to analyze the pollution data collected in different locations to find redundancy of the data so as to decrease the number of active sensor or prolong the sample interval. Like we know, as addressing global warming become more important in the government policy, however, local authorities are likely to be and increasingly required to monitor and decrease greenhouse gas emissions of their regions. Information on greenhouse gases is consequently additionally wanted for long-term monitoring purpose with comparable linkage to traffic and weather data to apprehend the contribution of traffic environmental condition.